All right, Algebra 2, this is the second part of your complex numbers video because it cuts me off when I'm too long. So here's the second part. This is more the solving piece, like I mentioned when we were talking about evaluating the square root of negative radicals. So when we need to solve this, we would set it up just like any other problem that we do in class. We need to subtract 4 on both sides, get x by itself, right? So we have x squared equals negative 4. Now from this point, in order to undo something squared, right, in order to get that out of there, we have to square root them. When we square root both sides, we actually get x equals the plus or minus option. 4 is a perfect square, and there's a negative under the radical. So we have two answers for this one. Okay, the next one, we need to add 11 to both sides. So we have 2x squared. And then we have equals negative 36. Change my color. Divide by 2. X squared equals negative 18. And then our radical, right? So we've got a square root there, square root there. That gets us down to our x by itself. But then we have to simplify this radical. And again, we have an I out here, and then we'll have 9 times 2. And the square root of 9 is 3. So we have plus or minus 3i square root of 2. So this is a lot, right? We have to consider lots of options. We added 2 new things. One, plus or minus might be new to you. So we have to think about when we're solving having a plus or minus when we have an even root. So that would be like a square root, a fourth root, a sixth root. We have to consider this plus or minus option. Then we have to consider simplifying a radical, which will be 9 times 2, this whole piece. And then we have our negative under the radical, which is I. So just remember to think of all of those things as you're doing your homework. Okay, so go ahead and pick 3 of these. I'm going to walk you through 2 of them, and then I'll pause and show you the answers for the other 4. So I'm going to choose a couple harder ones, actually. So this one, we just need to get this x by itself, right? That's our goal. So we'll have to square root both sides. And 13 is a prime number, so we actually get plus or minus I roots of 13. And that is our final answer. Okay, let's choose one maybe over here. It has a funky answer. Let's choose that one because the answer is funny. Okay, so we'll add 7 to both sides. And then we get 3x squared equals negative 24. Change a color here. Divide by 3, divide by 3. And then we have x squared equals negative 8. Okay, so when we square root this, we square root both sides, we have to consider what perfect squares fit into 8, and it's going to be 4 and 2. So we'll pull the I out, right? And we have plus or minus, the square root of 4 is 2, so that goes out here. We have our I, and then we have our square root of 2. Okay, and if you need extra help like simplifying radicals, just go to Khan Academy and type in simplify radicals. And there will be extra help for you on there as well as other resources online. All right. Let's pause the video here for a minute and then we will move on to the answers for the remaining. All right, here's the remaining answers for all of those. Go ahead and pause and take a look at those, compare your answers, write down any questions for your teachers for synchronous learning time should you have them. All right, so this is where we talk about zeros. So I've told my classes before, we say zeros, we say x-intercepts, zeros, x-intercepts, we can say factors, right? All those words are almost interchangeable. And we're talking about the same point on the graph of those for those shapes, for these quadratics. So if I have a quadratic like this, these are the zeros, the x-intercepts. I can see them in factored form, right? So that is what we are saying when we say these. So what that means is that we can figure out how to factor this out. And for this one, we're not necessarily, we're just pulling something out of both of these terms. We just have two terms. So to factor this, we would say f of x equals, I know they're both divisible by 4, so I'm going to pull that out and say x squared equal, whoopsies, x squared plus 5. Okay, so now I know that I can find my zeros using this. So we actually use the zero product property and talk about this piece equaling 0. So when we solve for this, we get x squared equals -5, and therefore x equals plus or minus I roots of 5, because we square root both sides. So this actually means that this quadratic does not touch the x-axis, right? So it could be something like this. All right, I'm going to walk you through these ones because we have some time to do that. If you don't need me to walk you through them, then pause me and then look at my answers at the end, okay? So it's saying find the zeros. So we need to just set this guy equal to 0. So we'll have 0 equals x squared plus 7. We will subtract the 7 over to the other side, and x squared equals -7. Now we need to square root it, and we get plus or minus I roots of 7 equals x. Okay, we need to factor this one. So go ahead and I guess you can pull a negative out if you want to, and then you can do x squared plus 4. And that's our f of x function. And then we know that this guy has to equal 0 somewhere. So we say x squared plus 4 equals 0, and x squared equals -4. Therefore, x equals plus or minus 2i. And you would get the same thing for that if you didn't take a negative out at the beginning. All right. For this one, we're going to set it equal to 0. When we subtract 1, we get -1 equals 9x squared. And now we need to divide by 9. So we get -1/9 equals x squared. Now I can still take the square root of this, right? So it's another property that we have, that if we have -1/9, that is the same as saying, if I take the I out, it's the same as saying the square root of 1 over the square root of 9. Okay? So that's how you can think of it if it confuses you this way. So we'll take the square root of both of those, and actually, I don't want my negative there. So we want a plus or minus 1/3 I equals x. All right, again, write down any questions you have for your teachers. Hopefully that wasn't too rushed, and we'll see you in synchronous time.